yesterday I made a repo, created a repo called Face here, two Docker servers, Flask API servers that one is called video to frames, takes binary video, returns you extracted frames, and inside Face, I got it from here, I forked it to my GitHub and then made some changes. I just wrote some scripts that act as a server and a client, and there are the instructions and everything. So let's get this started. So alright, where was I? Right, so in order to get this running, we have to run Docker container. Well, you don't have to, but that's the safest way. And then, so I have written it down here. Let's first run this. I actually built this, the first one. Built two Docker containers. Let's see, okay. No. It was repos and face, right? And then here, if you go to video to frames, there's Docker file, then you can build Docker container. Let's just build straightforward. And I'm just gonna build, T means tag. I'm gonna build video to frames, right? That is on this directory. It's gonna get this Docker file, and then it's gonna build it. The Docker file is, this is gonna be quick. It's nothing special. Just add, so there's a Docker file built. That was the video to frames. It's about 1 gig. All right. So if I run this, Docker run interactive T, I forgot it. Remove when I just cancel it. Port forwarding 110100 to this one. There you go. It's running. Let's run a client that sends binary video to the server that's listening here in this port number. And then I can do so. You know what? You have to some install. Okay. Let's create a Python. Oops. I always only do Python 3.7 because I know it works pretty much safe everywhere. And then yeah, just some clients. Video to frames, here are requirements. Require runs client. So that's not a lot of stuff. Just JSON pickle, TQDM request to make requests, and that's it. And Pillow to process images. And then let's get this started. Python 3. Let's run it here because there's data. Python 3 client. No, video to frames and client. Help. It's gonna accept URL as this one, which is actually default, so you don't have to specify it. Everything is set to default except the video path, like that one. So that's all I have to do. There you go. You can change these numbers, and they're documented pretty well. So now this video has been processed. So if you see the data, there it is, images and extracted frames. So every 60th frame is extracted here, and then with the metadata. Metadata will show you something like that. And the images, data here. Yeah, so these are the images taken. And these just the images extracted, so there's not much going on here. So what gets interesting is the second service here, which is called Inside Face. So again, there's a client, there's a server, and there's a CPU version and GPU version. Let's first start CPU version. That's simple. All right, we have to get this running, this Docker container. Well, because yeah, you will see why that's the case. Here, let's go to Inside Face, and then we have to build it again. Yeah, this is gonna build the CPU version. So all the deep learning stuff will just run on CPU. It's pretty fast enough. It's not a huge model, so let's get this done. And the building will be quick too. Here, that one, the CPU version, just not a big thing at all. FFmpeg, some requirements here. Again, MXNet. I don't like this. It's not my favorite, but these original authors have used this as their default running framework, and then it is what it is. So GPU ID -1 means it's not using GPU when it's running the server Flask app here. So oh, it's done. Let's run this. Docker build was that one 9 seconds ago. 2.1 gig face analysis. Docker run face analysis on CPU, right? So yeah, it's gonna download the Retina face, that's for face detector, and ArcFace for face recognition, and GA for gender and age, which is not perfect. There's some better repos out there. Maybe I'm gonna replace this one with that one, but I don't have time for that now. Let's see the CPU usage. Alright. My laptop has 64 gigs of RAM, 16 threads, but one thing that's a bit shame is that the RTX 2060, I believe that's what I have. Yeah, it's only got 6 gigs of RAM, so it cannot fit much. Also, it's pretty fast. So there you go. It's running now. It's sitting at this port. The reason why I have to run 2 Docker containers now is that one, the client that I'm gonna run, which is the inside this client here, that's gonna first send the raw video to here, get the extracted frames, and here it's gonna send image one by one actually. So batch size is 1. Maybe there's another optimization that can be done there to get the face features extracted. The reason why I separated this is that not everyone, someone just want this to be done, not this, and also some people want to get both of them at the same time. I mean, you can modify client as you want. It's just that that's current implementation, and you can always change. Alright, that's gonna, what is it, inside face now, right? It's gonna run that. See, now the feature extraction is done. Yeah, you have to install NumPy. Inside face client. That's requirements. You have to install NumPy on top of that because I use JSON Pickle and it doesn't know what this NumPy object is. That's why throwing out you that error. There we go. Alright. So it's pretty slow, as you can see. It's using all threads, that's good. But it's running on CPU, just a bit slow. So now as you can see here, along with the frames extracted, you have every frame with the facial features, bounding box, age, gender, face detection, probability, and also the 512 dimensional ArcFace vectors, which you can use for face recognition. And yeah, that's what's gonna get extracted. Let's run the GPU version. I mean, the driver has to be there, but you don't have to install CUDA actually, because it's gonna be built on, the CUDA library is gonna be built in the Docker container. So your system does not have to have it, but of course your system has to have NVIDIA driver installed. So Docker build. Now we have to specify the file name, because we're not gonna use a default Docker file name. It's gonna be Docker file CUDA11. Tag it to face analysis CUDA. There you go. Build it. It's gonna take some time. It's gonna fetch a lot of stuff. Here it's gonna install. It's gonna fetch this image. I think it's made officially by NVIDIA. CUDA driver, CUDA library 11.2.2, not this one. I commented out, and CUDA DNN 8. Ubuntu 20.04, It's gonna install some stuff and it's gonna run GPU ID 0. Yes, I think if you have to get this running, you might throw some errors if you have not installed NVIDIA specific Docker too, because like it's not native vanilla Docker, but it's this you might have to get this running and make it NVIDIA Docker. I think I have done that. I really wish I have at least 16 gigs of memory. You know, I was checking out today. There are finally RTX 3080 laptops that have 16 gigs of graphics memory. That's gonna be amazing. Then I can run so many stuff with batch size, high batch sizes and everything, and Docker. Just get everything running on Docker containers. This one I believe has specs. Yep, it's got 16 gigs. That's amazing. What's happening there? That's MXNet again, throwing the problem. So the question is, now that I have so many things running here, can I fit 3 deep neural networks in this small GPU now? I tried it and it worked, but I cannot guarantee now. There are always some stuff running. So let's see. Okay, building is done. Oh, that's the face analysis CUDA. 6.6 gigs per run. Here, this is important. You have to let know Docker that it has to have access to GPUs, otherwise it can't. Again, might be NVIDIA stuff, NVIDIA specific GPU. We're gonna port forward this port forward to that port, because that's what the Flask app is listening within the Docker container. So let's get this going. And then face analysis has face analysis CUDA. Alright, has to download this again every time I run it. I mean, even if I cancel it, even if I've done this and run Docker container again, it's gonna start from the scratch. So there must be a way where you can catch this or insert that from the beginning. I don't know. Maybe I'll work on that at some point. There's a lot to work on. Like I said, it's receiving batch size 1. The deep learning models here. It can be probably accept higher batch sizes. Then of course you need bigger GPU. Even the CPU model should be able to accept more than 1 batch size. There you go. Extracting features. Out of memory. Sometimes it works, because now there are so many things running. If I turn that off, which I don't know what it is. Okay, now we have more memory at disposal. Alright. Oh, no, that just stopped, right? Okay, have to fix that too. Alright. Run it again. Alright, see, now we have more memory. Maybe now it's gonna run. Yes, it's running on GPU now. Right, see, it was much faster than running on CPU. Problem is the memory. Alright, so extracted features are here now. Let's turn both of them off and see what it has extracted. So let's open this image, and these are the face analysis vectors. So image is just a pillow image object, so it's gonna directly display this on Jupyter Notebook. And the size is that one. And then the features, face analysis features here. Let's see what kind of stuff it has. So So there are two faces detected here, right? So it's got two elements inside this list, and then the first one, think that I am 19 years old. I'm not sure if this one or that one. The second one, think I'm 21. Let's see, this time, gender. I believe 0 was female, so first one. Okay, first is a female, the second was male. And what else? Yeah, bounding box around there. Gender, landmark, 5 landmarks, 2 eyes, 1 nose, and the 2 ends of the mouth. Normed embedding, that's the normalized embedding vector. Now let's draw this with that one. That thing. Draw it. Yes, now draw 2 rectangles around the face. And then, yeah, that's, you can do other stuff too. God, it can display everything here. I'm too lazy to do it. But I want to figure out which one it classified as a female and which one is a male. Okay. Okay, it stopped. Very good. Very nice. That one is the one that got me as a female. Ooh, never mind. Too lazy. Alright, that's what it is.